Okay, so today we are looking at sampling and displaying data. So we talked earlier about the different sampling techniques here, and I suggest you read these ones through and read what they sort of apply to. But we are going to be looking at a question looking at stratified sampling, where we select a random sample of a certain number from each of the strata or categories. So in this question here, Mandy asks the students in her school to take a memory test. The students have to remember as many objects as they can from the 20, and the results are shown in the table. So we have to figure out how many students to select from each class. How many students are we going to select from class 7? So we're taking 40 students from a total of 150. What percentage of the class are we taking? So our percentage of the class that we're taking is going to be 40 over 150. So if we put that into our calculator and work it out as a decimal, we get, this is roughly 0.266 recurring, like this. So that is roughly 26.7% of each class. So let's use that number and take that number, and the number from class 7 is going to be 40 over 150 multiplied by 20. So what percentage of 20 do we want? So we take this number, we multiply it by 20, and that tells us, unfortunately, 5.33, which means when we round it, therefore, 5 from class 7. Okay, so in B, how many students do we need to collect from each class? Take a minute now and work out what, firstly, have the decimal. And then we're going to take 5 for that one. So have the decimal before you do the rounding, because we need to make sure it all adds up to 40. So I'd like you to take a couple of minutes to work out how many do we need from each class. Okay, let's have a look at our values. So for the second one, we are going to have 7.2. This one should be 7.2, 7. Then our next one is 23 students. We give us 6.13. So that one's going to be 6. 6.9. That one's going to be 7. 30 times 8. This one comes out as 8 exact. And then 24. 6.40. That one's 6. How many do we have total? So 5 plus 7 plus 6 plus 7 plus 8 plus 6. We get 39. We need one more. Which would you suggest we should change and why? Why, Barn? So Barn suggests this one, although it's 6.4, she is suggesting we change this one to 7. Why? Yeah, it's the closest one to be able to round it up. This value here has already been rounded up, and this one is actually, the error in the rounding is less than it would be for any of the other ones. Another good reason is it's also, it's a larger number, so the percentage is a little less. The percentage error is less in rounding up. So we would make that one 7 in order to make sure we have 40 in our group. Okay, we have an investigation here. Have a go at working in pairs through these questions now. There. Okay, how many dogs are in the population? Well, 120, it says. 120. Represent in a frequency table. Oof. So this one is a little bit trickier. Here we need to make a frequency table. Sorry? I will count a little bit just to show the technique. So with this type of thing, we're going to make a little frequency table for the data. Let me get some space here. So I'll do it like this. So for ones, I would literally cross them off. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this gives me 10. For the twos, 1, 2, 3, 4, 5. 1, 2, 3, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what was that? 16. And then 4, 5, 6, 7, 8, 9, 10. Oof. How many fours were there? 13? Fives? Sixes? Sevens? Eights? 9? Sorry, was it not? How? 1, 2, 3, 4, 5. 1, 2, 3, 4. So 9. And then 9's a 5. Is that 10's? 4. And then 11's. How many 11's are there? 1, 2, 3, 4. 12's? 3. 13's? 14's? 15's? 16's? 2. Just put a couple of lines across. Like that. Make it a bit easier to read. Wow. Which average can you read from the table? The mode. What is the mode? 5. No, not easily. You can read, obviously, all of them from the table, but the median's going to take a little bit of figuring out. The median's next easiest. Which data item is the median? There's 120 data items, so the 61st item is going to be the median, isn't it? So you'd have to just count down. Oh, you'd have to count down the list until you get to 60, and it would be in that grouping. Which method of finding mean is easier, from the raw table or from the frequency table? It's going to be easier from the frequency, typing this in. Typing all of the data in, you're so easily going to make a mistake typing it in. But once you've organized your frequency table, it will be easier to put in and find your mean. Why can it be helpful to organize the data in the table? It's easier to analyze. It's easier to error check as well. If you have got an error of some kind and you want to find it, you can zoom in and say, oh, wait a minute, I don't have enough 5s or whatever. How would you take a sample of 40 dogs? Which sampling technique would you use? Nope. The best sampling technique here to use would be systematic. So if you want 40 dogs, how would you do it?
Every third dog.
Every third dog. So you would this would be your sample, like this. You just go along. So how many ones are there in the sample? 4. How many 2s are in the sample? Yeah. How many 3s are in the sample? There are 6 threes. 6 threes. That would be, what type of sampling technique am I using? Systematic. If you're picking customers coming through a door, systematic is a good way to make a sample. If you take every 10th customer that walks through the door and then sample them, that's a good sort of technique. How can you decide whether your sample is unbiased? Well, if you use a good sampling technique, the whole point of the good sampling technique, it should be unbiased. There's a few ways you could do it. You should have the same mean in your sample. Your sample should have the same mean, should have the same median. These statistics should be the same. You could draw a histogram of the original data and draw a histogram of the sample. It should look the same shape with a different scale. Take a systematic sample of every 5 dogs, then find the mean of the sample. I'm going to skip that a little bit. Calculate the number of dogs in each age in a stratified. We're going to have to skip that a little bit. How do you decide on the best sampling method to use? Would depend on the situation. Here on this one, I think a systematic sampling is going to be sufficient for us to produce the right amount. That should work for this type of data. All right, so we are going to look now at box and whiskers plots, or box plots. We're going to look at how to calculate a box plot, and this data, this bit here, outliers. This is a really common question for IB exams. These formulas are not given on the formula sheet. So make sure you learn how to identify an outlier in a data set using this strategy. And I'll show you through some examples now. Okay, so we have data on shoe size of group of students as shown here in the table. So we can see the shoe sizes, we can see the males and the females. Our first task is to draw a box and whiskers plot for each of the two. All right, let me show you how to do the box plot for this one. So for the box plot, we need the 5 key data items. And what I'm going to do for this one is I'm going to share from my computer so you can follow me along. When you get your calculators ready in your hand. Okay, I'm just going to press on, choose a new, say no, always add a calculator page. So first thing we want to do is we wish to enter in our data. Sorry, I'm not sharing properly for some reason. Why am I not sharing? There we go. Can we see? Yeah. All right. So first thing we want to do is we want to add a list or spreadsheet. So we're going to add a page, add number 4. Our X column is our shoe sizes. So this is our X. And we're going to type in the shoe sizes. So 34, 36, 37, 38. 39, 40, 41, 42, 49. You notice on my data, I'm showing 3 decimal places. I want to switch that off. I can press menu. Oh, sorry, not menu for this one. It's document 7.2. See if that fixes it. change this one just to the regular float. Yeah. So next up, we are going to want the females. And type in their data, 2, 2, 10, 8, 7, 3, 0, 0, 0. And then put in a frequency for the males, 0, 0, 3, 7, 12, 9, 3, 1, 1. Okay, is everybody there? Are we all there? Okay, so what we want to do now, on your calculator, press Control, Add Page, add Data and Statistics, number 5. Here at the bottom, we're going to put our X values. It's going to organize the data like this. Then we're going to, on the Y values, we are going to put females. Bit of gibberish there at the moment. Now what we're going to do is change the plot type. No, sorry. Sorry, I messed up. Let me undo that. So I can press Control Undo and it will take off the labels. So we're just going to put the X values in, and then it will let us change the plot type now to a box plot. There we go. And sorry, let me just make sure the plot properties are correct. Add a Y variable for the males. No? Why am I getting it wrong? Yeah, you have to take those off like I did. Press undo and remove those. So let me run through this again. We've got our data typed in here like this. What we want to do is press Control, Add Page. We're going to add a data and statistics. We're going to start by adding our X values like this. Then we're going to press Menu, Plot Properties, and we're going to add a Y summary list, number 9. Add a Y summary list, number 9. So I'm going to choose the females. Draws me a histogram to begin with. And then I'm going to press Menu, Plot Type, and switch it to a box plot. So now we have a box plot drawn for the females. Next, I'm going to press Menu, Plot Properties, add another Y summary list, and this time I'm going to choose the males. On this point, it's taken out the outlier that we've got here. We'll come back to that later, but if we want to have the outlier included, we click Extend Plot Properties. So from the plot properties, extend the box and whiskers, and it will look like this. So in order to draw this now, we are going to use the trace, where it is here, under number 4, Analyze Trace. Right. So if I move left and right on this one, it will move along the different, so I can use my cursor keys here to move up and down between the different ones, and then I can read off the necessary 5 data points. So I need to draw the female's one first, 34. So, sorry, if we point with the cursor, you also get the values here. So to convert this onto my paper, you have to have a scale, and you're going to need to draw your scale carefully. So the first thing we need to do is we need to have a line. Let me get a pen going here. Let me get a pen. I'll use the line tool. Get a nice line. I'm going to do it in red so you can see it. We're going to need a scale like this. So you have to have a scale, and then you have to write the numbers in on your scale. So we've got 34 here, and we can go up in one. So 35, 36, 37, 38, 39. This one here will be 40. So this one's 40. Let me just put a tick mark there on 40. 41, 2, 3, 4, 5. That's 45 there. 6, 7, 8, 9, 10. So this one's 50. Let me label these ones up. 50 and 45. So you need to do 5 vertical lines on the 5 key data points for a box plot. So our lowest value, our minimum value for the females is 34. So draw a vertical line like that at 34. Then the lower quartile is 37, so 35, 6, 7, that's here. We draw a vertical line. All of these vertical lines should have the same height. Scroll across, there's 38, so we go up there like that. It's 38, and then 39, and we go up there like that. And then lastly, the maximum value is at 40, and we go up like this. So 5 vertical lines for the 5 key data points. You draw a line through the middle of the first 2. The next 3 you connect across the top and the bottom. And then the last 2 you draw a line through the middle. And we get the box plot for females. We should label it and give a scale. So here on our scale, this is shoe size. And this box plot here is for the female shoe size. Now we will do a box plot for the males. I'll just change the color. So our lowest value, if we point to that one, is 37. So 39, 38, 37. That's going to be here. Our next value is 38, 39, 40. So 38, 39, 40. And then our maximum value is 49, which is over here. So a line through the middle on the first and last, and then join the middle 3, top and bottom. And then label this as males. So in the last question, we're asked to comment on whether there are any outliers. So in order to find out if there are outliers, we need to show the calculation. But we can make it happen on the box plot. I took the outlier away to begin with. So in the plot properties, you can say show box plot outliers here. And then this shows you the outlier at 49, and it shows you how the box plot should look. So if we want to redraw the box plot now, indicating the outliers, I would take off these lines here like this. So the new maximum is at 42. Our new maximum is at 42. That's going to go there. And then at 49, we draw an X to show that there's a data item here. And this is how we draw a box plot indicating the outliers. Now, you're going to have to show your calculations for that as well. So we need to show the calculations. In order to show the calculations, we need to find, I'll do this with my pen. In order to show the calculations, we need to find the interquartile range. So the interquartile range is Q3 minus Q1. We can get that from the box plot. So 38, 39, 40. Q3 is 40, Q1 is 38. So the interquartile range is going to be 40 minus 38, which will equal 2. So to find the outliers, upper outliers are equal to Q3 plus 1.5 times the interquartile range. So Q3 is, we can just read it off the graph again. Q3 is here, it's 40. So this is going to be 40 plus 1.5 times 2. So outliers are anything bigger than 43. Outliers are anything bigger than 43. And we can say that 49 is bigger than 43, which implies that 49 is an outlier. Okay, that is it for today. Have a go at the exercises. Yes. Have a go at the homework exercise. Make sure you use a ruler and that you draw your diagrams large on this one when it comes to the grading. So when you upload your homework to the Google Classroom, for your histogram and your box plots, these need to be drawn large with a ruler. If your quality of your diagrams is not sufficient, you will score poorly for this homework. Barn! Yeah, of course.
Wasn't that the one that was just minus 1.5?
Yeah, so you have the formulas for them here that I highlighted.
Yeah, what do I label here? I missed that.
Male and female.
Yeah, but do I need to label like the quartile?
If you've got your scale drawn, you don't need to. You don't need to if your scale is drawn.
Should I fill in the...
If you're sketching it and you don't have your scale, you would label them. But you always.
So the examiner could see that this, for example, is 38, this is 39, and this is...
Exactly. They give you, on this type of question, they always give you a little bit of a grid paper on the for you to draw it on. This is drawing a box plot is a super common question. It will be on your semester exam. Finding outliers. You know you can zoom? Oh wait, what is this? Is this the PDF?
Yeah.
You want to use the online one. This PDF is out of date. Oh, no, it's the... Why don't I see This isn't the school version. Yeah, it's the same one and everything, but it looks like click on this. There's a couple of options here for clicking on going to straight away. Save the other time. Yes.
I don't think it's charges. Put me on test mode.
You're already on test mode.
Actually.
Yeah, that's why your battery's failed.
It's not.
So after you've had it plugged in a while like this, with it charging and on, when you take it off, there's still no battery. Your battery's dead.
You don't have a
Sorry? No, it's not the charging the issue, it's the fact your battery is broken. Your battery no longer holds any charge. So when it's plugged in like this, it's working.
What does it mean?
You need a new battery.
Why? Sarah just got it.
Take it back then. Sometimes they come, at least
I
fail.
got it from Amazon.
Yeah.
I don't think it's still like returnable.
How long ago did you get it?
Last year, like February.
Alright,
This year, basically.
that's a long time.
20
So
February.
what happens if they get left in a warm environment, a very hot car or something? They get left in the car, it damages the battery. So if my stuff was stored in a box and somebody left it somewhere and it's got
It's
hot,
always like in my room or my bathroom.
yeah, it never left in the car.
How can I know?
I don't know why it's failed. It could also be that it was a bit damaged when you got it and they left it in a hot environment and it worked for a while and then it stopped. Very common problem with these calculators in this country, not in other countries.
What do I do to change? Do I have to like get a new calculator?
Get a new calculator. Some people, I have heard some people finding an IT guy that can do it for them, fix it. Yeah.
Here?
In Dubai. I have heard now that some guy, I took it to the mall and I took it to this IT, those little kiosk type shops that do mobile phones and stuff. And they
Yeah,
fix
but I'm not spending 800 It's so expensive.
it. Is. It's awful.
It's awful.
It is awful. I would be furious.
So for this question, would you want us to make a frequency table?
Yeah.
But is it?
Find the mean. Yeah, it's up to you. It's a bit of a pain, that one, but yeah.
What's the, is there any other
Type them all in. I think a frequency table is a little better. But it's harder because they're not in order. You need a calculator for exams.
Yeah, but now we do the exercise.
I generally recommend using GeoGebra. Martin, you're not working. No, just sit and chat with your friends for 20 minutes. Math isn't important. Why not take a long walk down the corridor or visit the bathroom?
Sir, you weren't making jokes today.
I wasn't, or I was.
You weren't.
No? I'm sorry. I wanted people not to wet themselves. Sama, will it help if I lend you one for today? Do some questions. Do a favor to future Sama.
Yeah.
Do her a favor.